All right, welcome back. So we've talked about how to input your data in here, and you're also seeing with that E1 column in our table that we have already calculated our residuals here. And we can turn them on if we wanted to, but we don't want to right now. Right now, what we want to do is, let's say we don't think this is the best model. Let's say we come to the conclusion that we have a curved pattern for our residual plot here. And we're told in our scenario, our question, however we're being asked this, that we want to do a couple things. We want to transform, we're going to transform y to our favorite function, square root y1. Now, how we do that, there's a really easy way. Over with our E1 column, we can come over here, and you have a couple options. You can come down here and do your keyboard and type and just press square root. I personally find it easier just type SQRT. Either way is fine. Then press Y1. Now, what this does for you is now it's going to create a new scatter plot, this time in the purple colors, with our transform data of x versus square root of y. Now, a couple things as we're looking at this. One, right now, you're not seeing this zoom fit. That's because Desmos is now working at y1 and square root y1, as well as this linear regression down here. It's got too many things to look at. So it's thinking, okay, we already have the best data fit here. You can see, if I scroll away, like, it's trying to get everything. But what if we just want to look at that square root transformation? Turn off our green y1s. And now we can see it's still not the best because it's still trying to graph this linear regression. You can turn off that linear regression and see a little bit better here. I think the best thing we can do, though, is actually go down here to y1, switch it to square root of y1. Now, when I click this, I want you to watch what happens to our equation and our r squared and r. And then we can do this line, and we see that now our information has changed a little bit. We can see that our equation has changed. We can see that our r squared and our r have changed. And if you don't believe me, you can see again. They're not changing much, but they are slightly changing in the r squared and r. It's definitely changing in our equation for our least squares regression. And you can see that your linear regression line Desmos is creating is following with you. Another thing that is following all of this transformation are your residuals. So again, watch up here at this E1. I go back, our residuals are changing because now our prediction is different than our actual values for the square roots. One thing to note though, like it's a very important thing here, and then we're gonna look at the residuals real quick. This equation, we already know it's for getting the y hat. It's not in a plus bx, it's got them flipped. It's also not y equals 5.50791 plus 0.456796x. We would probably want to, round a little bit. But we transformed our variable of y to square root of y. So if you wrote this on your paper, this is not our transformed model we're looking at. Our transformed model would have to include square root of y. And one thing I don't want you to look at is what that line looks like. That's not the point here. We still know it's linear. We would need to remember that the square root of y here has to follow when we write this on our paper, when we talk about this model. Because if I asked you to predict the number or the distance traveled, if I gave you 20 rubber bands for x, you can't just plug in 20 and then fill this out and be great. And we know that here because if we type this, that's only 14 rubber bands, our distance of 20. Or our 20 rubber bands are giving us a distance of 14. And we can already see here that's not the case because our original data, 0 rubber bands, was already 30. Like, that's a wild one. So that's where knowing, okay, but it's the square root of y. And why is that important to me? Because now when I get this 14.64, I have to remember, hey, this is going to have to be undone by squaring it. And we can see that our distance is now 214 for 20 rubber bands. Our predicted distance would be. So just don't forget, you have to follow through with all of that. This can even be done, we can look at the residuals. So again, I highly suggest when you're looking at residuals, you turn off everything else and zoom fit your residuals. I think personally here we can see another probably good curved pattern. I'm not really seeing anything here. Sorry, it's not a curved pattern. I'm seeing a good scattered pattern. There's nothing here that would signify this is a bad model. I think this would be a fairly decent one because we are seeing just a scattered pattern. There's no interesting pattern here. We can also do this for ln. So I know this video is a little bit longer, but you can, again, you can come down here. If we're looking at natural log or log, it would tell us we're looking at that. You can come down here and find it. You can also see you have a lot of different statistical things here we'll get to throughout the year. But we don't care about that because if we're just looking at natural log, just ln y1, and we can see yet again, I'm going to turn off that residual plot. We can't see our data. Now we can. This is a little bit, it doesn't look as great. I'd be interested to see what the residual plot looks like. But now we can see our least squares regression line, our transformed ln of y data, our equation with, again, it would have to be ln y, not just y when you write it down and start solving things. Interesting. Let's look at our residual plot just to maybe see. This one probably has more of that curved pattern. I would say you're starting down here, you're coming up, and then it's going back down. So overall, I don't think this would be your best model. I think you'd probably want to look at the square root probably being a good model. I think, honestly, the just y, x versus y is also a good model. So I don't think you'd really be too stressed by saying your best model is this guy right here. But those are just some things. I think that kind of explains nearly everything you would need to do when you're looking at scatter plots and two quantitative variable data. So that's all for this one. We'll see you next time.